So, we're going to be going over L'Hopital's rule today and going over indeterminate forms. I have 1 to the infinity, 0 to the 0, and infinity to the 0. These are the indeterminate forms that we're going to be going over today. Now, here is just like a rule that you should know, kind of also like just, not guidelines, I don't know, stuff that you should know going into these types of problems. I'm working with these limits. So yeah, just read this over in your mind, you know, sink it in. You got it? Alright, sweet. So we're going to be working with this example, and this is all you need to know. Once you can do this problem, you can solve any or most of these indeterminate forms. Okay, so we're taking the limit as x approaches infinity of x to the 1 over x. Now this is the indeterminate form, infinity to the 0, because if you plug in infinity into x, you should get infinity over 1 over infinity, which is infinity to the 0. Alright, so first we need to define the following: y equals x to the 1 over x. Okay, so to do this, we're going to take the ln of both sides. So we should get ln y equals ln x to the 1 over x, and that should also equal 1 over x to the ln x, because you bring this to the front, which equals ln x. Sorry if my camera keeps moving, I don't know. As long as you see the problem, you're good. Okay, so now we're going to take the limit of both sides of this. So we can take the limit of ln y as x approaches infinity, and this should equal the limit as x approaches infinity of ln x over x, because this is what we get for y. Ln of y, I mean, yeah. And that should equal the limit of 1 over x over 1 as x approaches infinity. And then plugging in infinity, we should get 0. Alright, so we just used this is a L'Hopital's rule problem. And so now looking back here, we notice that e to the ln of f of x equals f of x. So that also means e to the ln of y equals y. Alright, so knowing this, we can use this to solve the limit above. So we could write it as the limit of x approaches infinity of x to the 1 over x equals the limit y x equals infinity. And as you can see, if we look back up here, since y equals x to the 1 over x, we can just plug that in for this. So we can just plug in y, which equals the limit of e to the ln y as x approaches infinity. And see, same thing here, just plug this in for y. Bang bang, schmiggity schmang. We're doing good. Okay, so now we can use the limit above here to solve this limit that we wanted to solve all along. Freaking sweet. Okay, so we take the limit as x approaches infinity of x to the 1 over x, and this equals limit of y as x approaches infinity. Showing all my steps here, you know? Can never go wrong. Showing all your steps. Limit of e to the ln y as x approaches infinity. Alright, so now and then we can write it as e to the limit of ln y as x approaches infinity. And then that equals e to the 0. And now if you notice here, oh, sorry, there you go. Can you see all that? Alright, just making sure. So if you notice right here, you can plug in 0 for that, because the limit of ln y as x approaches infinity equals 0. And so, what's the, oh, okay. So e to the 0 equals, you should get 1. And there you go. That's your answer. Now, I think we're good here. If you have any questions, just ask me in class. If you're watching this from the future, just ask Hein. He's a homie. All right. Hope you enjoyed. I'll see ya. Have a good day.